Welcome back to another brand new installment on the topic of heart of algebra. This time around, we will talk about exponents. This is several part series of videos on this topic because we have addition of exponents, subtraction of exponents, multiplication of exponents, and division of exponents. So there's going to be several parts on each of the topic of addition, subtraction, multiplication, and division. We're getting started with addition. So without further delay, let's get started. Here's the first problem. The first problem states, if a squared equals 35, b squared equals 52, then what is a power 4 plus b power 6? Okay, so what can we do? Here, if you notice, the best way to approach this type of problem is the given information are both in squares, right? And what they want is not in squares. So is there any way you can convert what you want in terms of squares? If you can do it, then you make your life easy, and the problem literally takes maybe 30 to 40 seconds to solve. So let's go ahead and actually write what we want, which is a power 4 plus b power 6, right? How can we express a power 4 and b power 6 in terms of cube? This is something we would come across. So let me go ahead and write the logic here. If you have a power m power n is same as a power m times n. In other words, if you have 2 power 3 power 4 is same as 2 power 3 times 4, which is 2 power 12. Just remember this. As we go through different problems, I will tell you a different logic. But for this problem, this is what we want. So if you want a power 4, how else we can work back so we could get a power 4? So that means if you write it as a squared over squared, right? That's same as a power 4 plus b could be written as b squared over cube, right? You could do b cube over squared, but that won't help you because b is expressed as a square, right? So that means a squared is 35 squared plus b squared is 52, and you cube it, okay? So if you do the whole answer, I think this problem was part of the calculator section because I don't think people will have time to do these manually. Okay, so 52 times t times 52. So it's 140608. If you add these two together, so the answer is 141833. Right. Once you figure out how to set it up, the problem didn't take much time. So the key here is, or the takeaway is the step right here. Okay, and where do we get that logic is from this expression right here, right? Because what we want is a power 4 plus b power 6, what is given is all squared terms, then we need to figure out a way where we can convert powers that are not square. Then if you can get it into square powers, then we should be able to literally substitute and solve the problem, right? So here's something I do want you to remember because I don't think these equations will be given on the test. All right, without further delay, let's continue with the second problem. We have 2 power 3 plus 2 power x plus 1 equals 72. There's two ways to do it, but I'm only going to show you the easier way, which is 2 cube is 8 plus 2 power x plus 1 equals 72. 2 power x plus 1 equals, if you subtract 8 on both sides, is 64. And again, if you, for this problem, the logic is if a power m equals a power n, then m equals n. Similarly, if you have 2 cube equals 2 power x, then x equals 2. Okay, this is the logic and this is the takeaway. Okay, as we do different problems with different takeaways, I would circle and indicate them to you so you don't have to do it. Now we're literally almost close to getting done with the problem. Here our base is 2, right? So we need to have a base of 2 raised to some exponent that will give you 64. And if you notice, 2 power 6 is, I believe, 64. So if you do 2 times 2 times 2 times 2 times 2, that's 64. Okay, so we have two identical bases. This is very similar to what we have here. If this is the case, then x plus 1 should be equal to 6. So x should be equal to 5. Okay, if you know what the logical expression that you're applying into the problem, then you can literally do addition, subtraction, multiplication, and division exponent problems very easily, right? Let's continue. Okay, if x squared equals 11, then what does x power 4 equals to? Again, a power m power n equals a power m times n. If you have x power 4, but again, what is given is x squared, how could you express x power 4? In other words, you're working back into this format. If you can get it into this form right here, then you can always do the problem. X power 4 can be expressed as x squared over squared, because x, if you express it in this form, x squared raised to the power 2, that is same as x power 2 times 2, which is x power 4. In other words, you need to know how to go forward, but you also need to know how to go backwards, just like problem 1. Okay. In other words, if x squared equals 11, but what I want is x power 4, which is x power 4 is x squared, right? Whole squared. And we know x squared is 11, and 11 squared is 121. It's very simple. Again, this is the takeaway. This is very similar to problem 3. Simplify. The key here is all exponents must be positive. So you can start however you want to start, and you may finish with the correct answer. And there may be more than one correct answer, but you must make sure that your exponents are positive. What they mean is it must be x power plus a, or 2 power plus 3, or 3 to the power 11, so on. All of these are positive exponents, right? That's what they want. So if you write it as x power minus 2 times y cubed, and this is multiplied by x power 5 times y negative 4. For these type of logics, when you have a power x times a power y is same as a power x plus y, okay? Because we're multiplying all of these terms, we can isolate the x's and y separately. So in other words, x power negative 2 times x power 5 can be isolated into a pair with y cubed times y power negative 4. The bases are same here for this pair. So in other words, it's x power minus 2 plus 5 times y power 3 minus 4. This is same as x cubed times y power negative 1, right? But they want all exponents must be expressed as positive, right? Y to the negative 1 is same as 1 over y, right? And y raised to the power 1 is y, so we don't really account for that 1. But in other words, a to the negative exponent of b is 1a or b, okay? If you apply that logic here, then it will be x cubed over y. And this is what we want. This is correct as well, but the question clearly states all exponents must be positive. So we're expressing this answer here as x cubed over y, okay? All right, again, another problem for practice. All exponents must be positive. So we have x power negative 3 over x squared. Again, all of these terms, the y power 5 is in the numerator and y to the negative 1 is in the denominator. To do this sort of problem that involves a ratio, if you have x power a over x power b, that is same as x power a times x power negative b, which is same as x power a minus b. In other words, x power a over x power b equals x power a minus b, okay? So let's convert the denominators into, bring them up to the numerator. In other words, x power negative 3 times y power 5. And then if you bring the x squared to the numerator, it will be x power negative 2. Whatever is positive in the denominator, if it comes to the numerator, it becomes negative. If it is negative in the denominator, when it comes up to the numerator, it becomes positive. So in other words, y will become plus 1. Again, just like we did in the previous problem, we can isolate the common bases together. In other words, x power negative 3 times x power negative 2, that's one pair, and the other pair is y power 5 times y power 1, right? You don't have to say show the plus. I did it here just to show that when it comes up, it becomes positive. Now, again, this is the same as a power m times a power n equals a power m plus n. In other words, this would be x power negative 5 times y power 6. Again, all exponents must be positive. So you can retain the y power x in the numerator, and when you take the x power negative 5 to the denominator, it becomes x power 5. And that's it. Right? This is a pretty unique problem because of the negative, and that can cause trouble to some of you because there's just too many negatives in the whole thing, right? So here we have, again, it clearly states all exponents must be expressed as positive, right? So here's how you do it. You can substitute the negative 11 as, for time being as y, okay? Just to get rid of that y from the picture for now, okay? Which makes your life easy, okay? You don't have to do that, trust me, you do not have to do that, okay? But for some of you, that negative will cause unnecessary chaos. So just to eliminate that, you're not going to be spending any more time than you would if you didn't. In fact, this might even eliminate any errors that you might cause keeping the negative in front of the 11. So if you bring the denominator, which is the y power 12 to the numerator, it'll become negative. This is same as, again, a power m times a power n equals a power m plus n. So that's y power negative 20. And then you can take, okay, the term back to the denominator. So it'll become y power 20. Now just go ahead and substitute, again, if you keep the y within the bracket, just replace the y with the negative 11 and put the 20 back up. That's it. Now, you could have done this without replacing the negative 11 with the y. For those that are already comfortable with taking tests and are comfortable with the material, they have the luxury to do a few things that others don't. If you're struggling and you want to improve your score, or you don't want to rush and make a mistake, if you take those stands, then I suggest you make the substitution of the negative 11 with y. Honestly, see, the only thing we did is just replaced here, and that didn't take more than 10 seconds, right? So you have nothing to lose. So if you have to make a substitution to eliminate any chaos or any confusion, please do it by all means. Okay, this will be the end of this video, which will be part 1 in addition of exponents. I think there's more videos on this topic alone. So let's go ahead and tackle the remaining 2 problems. Again, there's a difference between, okay, the key here is it's a play of how you visualize things. That's what they're playing with. They're playing with your brain, okay? When the 0 is above the exponent, irrespective of, say, negative x to the 0 is 1, x to the 0 is also 1, because any number raised to the power 0 is 1, whereas negative x to the 0 is negative 1. This is not the same thing, okay? These two are not the same thing. Negative x raised to the power 0 outside the bracket is not same as a negative where only x is raised to the power 0. Why do we get a negative 1? Because we said x. Now here it's the same thing. X raised to the power 0 is same as x raised to the power 0, whether within or outside the bracket. So here, this term is 1. The negative is not raised to any exponent, whereas here the negative is also included in the exponent, which is why we said that's equal to 1. So this becomes negative 1. Okay, now we know negative 3 raised to the power 0 is 1, and negative 3, and only the 3 is raised to the power 0 is negative 1. Now let's go ahead and substitute this whole thing with 1, which means the first part of the term is negative 1 time minus negative, and this whole thing is still -1. Okay, please retain the brackets. The brackets are life savior in these type of problems. Irrespective of how good you are with your math, you could still make an error because you're trying to fight for time. And that's precisely what people that create these questions are trying to do, is manipulate your thoughts. Okay, when you're in a hurry, you might see these two as similar, and you would jump to an answer that probably will be there, one of these answer choices, and you're going to get it wrong. Okay, and also make sure to use brackets. So this comes out as -1. Negative times negative is a +1. So the answer is 0. So the takeaway is this. These two are not the same. They result in different outcomes, okay? And I've shown this even with the x's, which is generic. This is for the specific problem. You can use either one, but the idea here is these two do not take the same meaning. All right, let's continue with the last problem in this video. So we have 3 times √18 plus 2 times √50. Now, if I had given a multiple choice for this particular problem, it would have probably helped you a little bit. But here's what they want you to do is simplify this further, right? Which means how else you can get 18 using two numbers. At least one could be part of a square root, okay? So 18 could be written as 9 times 2, and 50 could be written as 25 times 2. You might be wondering why 9 times 2? Why not 6 times 3, or I don't know, how else could you do? I mean, 18 times 1. Those don't have a square root, right? Whereas here, if you substitute 3 times, instead of √18 as 9 times 2, plus 2 times 25 times 2. Now, when you have square root of a times b, is same as square root of a times square root of b. So square root of 9 times 2 is square root of 9 times square root of 2. Square root of 9 is 3 times √2. Similarly, square root of 50 is 25 times 2, same as 25 times √2. Square root of 25 is 5 √2. So let's go ahead and substitute this here, which is 3 times √2 plus 2 times 5, or √2 times 5. I actually wrote that √2 first, but it doesn't really matter. It's 9 times √2 plus 10 times √2, right? Now you can take the √2 outside the bracket because it's a common term, which leaves you with 9 plus 10, which even simplifies further to 19 √2 or √2 times 19. They both mean the same. Okay, there's more problems. Each has its own different flavor. You may see 1 or 2 problems that repeat itself in a different way, because I do want you to have a practice of those sort of problems. But for the most part, every problem brings in a different type of flavor. And that's essentially what I want you to take away from these sessions. All right. If you like the content, consider subscribing to my channel. Share the video with your friends who are also interested in SAT math or ACT math. And thank you for watching. I'll see you with another video on addition of exponents. So stay tuned.